Hey guys, welcome back everybody. Hope you all are doing great. Guys, in the last video of this network topology configuration, we had seen how to merge two different companies' network together. Like you can see, this is my scenario, and in my scenario, I have network of two different companies. This is a network of XYZ Corporate, and this is a network of ABC Corporate. And both companies' network are connected together with the help of these two routers, router 1 and router 2. Router 1 is the edge router of XYZ Corporate, router 2 is the edge router of ABC Corporate. And to exchange routes between these two companies' network, we are running BGP protocol here, right? eBGP. We have eBGP neighborship between router 1 and router 2. Because see, the BGPS number on router number 1 is 100 and BGPS number on router number 2 is 200. And you know the benefit of using BGP between router 1 and router 2. Whenever we are merging a different company's network together, we should use BGP routing protocol, right, for the routing. The benefit of using BGP is scalability. As you know, BGP can handle large amount of traffic. BGP is good for AS management, for path selection, right? You have lots of options for path manipulation, for best path selection. Then BGP is good for inter-domain routing. As you can see, both companies are using their own AS number. XYZ has AS number 10 and ABC has AS number 20. So BGP is the only routing protocol which can make communication possible between different autonomous system, right? Then BGP is good for route filtering. As you know, we have lots of attributes in BGP, so we can use those attributes for the route filtering, for the traffic engineering, right? So these are the benefits of using BGP protocol between different companies network. Done. And guys, in the last video, we had seen the initial configuration of BGP on router number 1 and on router number 2. Today, we will see the advanced configuration of BGP, how we can improve the BGP configuration, right? According to our requirement, according to the business need, you are going to configure the topology. Yesterday, in last video, we had enabled BGP on router number 1 and on router number 2. After that, both companies network was able to communicate with each other. Like all departments of XYZ Corporate was able to communicate with all departments of ABC Corporate, right? But let's say for the security reason, you don't want to advertise server subnets to ABC Corporate, or from the ABC Corporate, see the finance department is there. So I don't want to advertise finance subnet in XYZ company, in XYZ Corporate, for the security reason, right? Or my scenario can be anything, right? Like in the last video, we had configured primary and secondary link. You can see between XYZ Corporate and ABC Corporate, we have two link. I have direct link between router 1 and router 2. In your scenario, you can have multiple paths. Like let's suppose here I have one router, here I have one router, and then these are connected like this, right? You can have more path as well between R1 and R2, but the configuration and the scenario is going to be same, right? Maybe one path is the primary path, rest all paths are the backup path. Sometime maybe you need to configure the conditional route advertisement in BGP. Like let's say my requirement is the server department should only be reachable from ABC Corporate if the primary link is up, right? If primary link is down, then router 1 should not advertise this subnet. That means router 1 should not advertise this subnet 10.1.4.0/24 from the lower link, from the backup link. Getting my point? So my scenario can be anything. According to my requirement, we are going to improve the configuration of BGP, right? So for internal routing, we are running EAGRP protocol. You can see in XYZ Corporate, we have EAGRPS number 10, and in ABC Corporate, we have EAGRPS number 20. This is for internal communication. For external communication, we have BGP protocol here, right? And guys, in last video, you had configured this upper link as primary link, lower link as backup link with the help of local preference value, right? Maybe you want to achieve load balancing between company A and company XYZ Corporate and ABC Corporate, right? So that is your scenario. That can be your scenario. So how to configure the load balancing? So what we will do, guys, today in this video, Today we will create some scenarios according to the business need, according to the real-time scenario. I will tell you some requirement, and according to that requirement we are going to configure the BGP, right? How to modify the BGP configuration to enhance the CPU utilization of router 1 and router 2, as these routers are edge routers. These routers are going to manage lots of routes, right? So I have to take care of CPU utilization as well to these devices, right? So how to reduce the CPU utilization of these two devices? If router 1 is advertising any unnecessary route to router number 2, how to stop that? Okay, so first of all guys, before starting the today configuration, let me verify the previous configuration and let me make you familiar with the last class configuration. And if you have not watched the first video, part 1 video, then please watch part 1 video first, then only you can get this video. Okay, now without wasting our time, let's begin. So here you can see I have access of all devices: router 1, router 2, router 3, router 4, router 5, router 6. Done guys. In XYZ corporate, you can see we have multiple departments like HR department, and for HR department we have this subnet 10.1.1.0/24, and last IP address from the subnet is configured on router. So like you can see, router 3 is connected with two department, HR department and sales department. For HR department, this is my subnet 10.1.1.0/24. So last IP address of this subnet is 10.1.1.254. So that IP address is running on router, right? Router 3. In the same way, from this subnet, last IP address is running on router 3. Then we have admin department and server departments which are connected with router number 4. And again, last IP address from these subnets are running on router number 4. In the same way, I had configured ABC corporate as well. Let me verify you and let me test the connectivity that all departments of XYZ are able to communicate with all departments of ABC corporate or not. Okay, so on router number 1, first of all, see, for the internal communication we are running EIGRP number 10. So IP route EIGRP, show me the all routes learned by EIGRP protocol. And see, I am learning all internal subnets: 10.1.1.0/24, 10.1.2.0/24, 10.1.3.0/24, as well as 10.1.4.0/24. So these are the internal subnets of XYZ corporate. In the same way, on router number 2, we are running EIGRP as number 20. So IP route EIGRP. Here you can see we have all internal subnets, right? 20 subnets in ABC corporate. And between router 1 and router 2, we are running BGP routing protocol. So IP BGP summary. You can see we have BGP neighborship. Router 1 have two neighbor, right? Because we have two direct link, right? Let's suppose distance between router 1 and router 2 between these two companies 5 kilometer and 10 kilometer, right? It can be 5 kilometer, it can be 10 kilometer, it can be 100 kilometers, and we have direct link, right? You can assume there are multiple routers as well between router 1 and router 2. Again, configuration is going to be guys same, right? So these are, let's say, fiber link between router 1 and router 2, and we have neighborship on both link. You can see first neighbor is 12.1.1.2 on the upper link, right? 12.1.1.2, which is the IP address of router 2 on the upper link. And this router 1 is learning 4 subnet from this neighbor. Here you can see received route, receive prefix is 4, right? From the lower neighbor, means neighbor on the lower link is 21.1.1.2, which is the IP address of router 2, and from this neighbor also router 1 is learning 4 subnet. Now, so IP route BGP, you can see router 1, which is the edge router of XYZ corporate, is learning all subnets of ABC corporate, right? All subnets of ABC corporate. So these are the subnet of different companies network. In the same way, router 2 should learn all subnets of XYZ corporate through BGP. So IP route BGP. Yes, you can see router 2 is also learning all subnets of XYZ corporate. Done. Maybe we are redistributing EIGRP into BGP, or we are advertising the prefixes of EIGRP into BGP. Done. Like on router number 1, to verify that, simply I can check BGP table. So IP BGP, and see this is BGP table of router 1. Guys, see the issue. Can you differentiate the self-advertised prefix and the received prefix on router number 1 by checking the BGP table? No. Both looks similar. By the way, these are the advertised prefixes, all 10 subnets, because all 10 subnets are part of XYZ corporate, and all 20 subnets are received route. And router 1 is learning receiving all 20 prefixes from both neighbor, from 21.1.2 also and from 12.1.1.2 also. Best is via this neighbor 12.1.1.2 because of local preference value. You can see here I had configured local preference value in the last video. Done. So local preference value from this neighbor is 200 and local preference value from the other neighbor 21.1.2 is null. So this is why best path is via router number 2. Done. If you want to remove it, you can remove this configuration. You can achieve the load balancing. First of all, I will show you how we can achieve load balancing here, right, between router 1 and router 2. But before that, let me tell you how we can differentiate route here, prefixes here, like advertised prefixes and received prefix. So right now, I think I am advertising these prefixes in BGP with the help of network command, right? The other option is we can redistribute EIGRP into BGP. And see, even for self-advertised prefixes, next hop is also not 0.0.0. So we cannot differentiate it. So for the differentiation, to differentiate the advertised route and received route, what we can do on the router number 1 and on router number 2, we can add the tag number. While redistribution, we have multiple options, right? While redistribution, I can add the tag, right? And with the help of that tag value, I can differentiate the advertised route and received route. Done. Now here, if you will check the BGP configuration, so let me say so run section router BGP, and you can see I am running network command here, right? With the help of network command, I am advertising these subnets in BGP, correct? And then I have one route map, you can see, for this neighbor for 12.1.1.2. Which route map? I had applied one route map with this neighbor, and name of route map is set primary path, and in which direction? In direction. Whenever it will receive route from this neighbor, it will call to this route map, right? If you will check this route map, so route map, and let me give the name of this route map. Here is the route map. You can see in this route map I am saying match IP address from the prefix list all route. This is name of my prefix list. So let me show you the prefix list also. So IP prefix list, and this is the name of prefix list. In this prefix list, actually I am matching all subnets, right? All subnets. So for all subnets, what we are doing, we are adding the local preference value 200, right? So route map is going to match prefixes from this prefix list, and it will match all prefixes, and for all prefixes it will set local preference value 200, right? For which neighbor? For this neighbor only, for 12.1.1.2 only. Done. This is the reason why so IP BGP best path is via 12.1.1.2. Now guys, I am going to remove this configuration, right? I want to achieve, let's say, load balancing here. So what I can do, router BGP AS number 100, and say do so run section router BGP. I'm going to say no to this command. I'm going to remove this configuration. Let me say no. Done. Then I'm going to even remove route map. Say no route map, and the name of route map is set primary path. Let me remove this route map here, and no IP prefix list, and the name of my prefix list is, I think, all routes. Let me, here it is. Let me copy the name and let me paste here. Done. Now do so route map. You can see we don't have any route map. Do so IP prefix list. We don't have any prefix list, and do so run section router BGP. We don't have any route map with any neighbor, correct? So now if you will check BGP table, do so IP BGP, you can see still best path is via 12.1.1.2. Now if you are thinking that perform in this case router 1 should perform load balancing, so no guys, by default BGP does not perform load balancing. By default BGP only install one route in their routing table, in their BGP table as a best path, right? But again, if you want to achieve load balancing, you can configure maximum path 2. By default, maximum path is 1. So I can say router BGP is number 100 here and say maximum path 2. Now this router will start performing load balancing, right? For all the subnets of ABC. Do so IP BGP. Now you can see, just wait for some time. I think I have to clear BGP table, clear IP BGP star soft in, and so IP BGP. Yes, now you can see it is performing load balancing, right? Best is again via 12.1.1.2, and this is your question guys. Tell me on the basis of which attribute this time router 1 is calculating best path, right? On the basis of which attribute a best path is via 12.1.1.2 via upper link, because there is no local preference. You can see from the both side all attributes are same. This is AS path, this is wet value. For received route, wet value is 0. Don't worry, I will give you some basic overview of most commonly used attributes as well in this video, right? For self advertised, you can see wet value is 32768. For received value, received route, wet value is 0. And then these are the matrix. Done guys. Now if you will check the routing table, so IP route BGP, so you can see this time router 1 is performing load balancing for all subnets. On router number 2 also we can remove the route map configuration, config T, and router BGP is number 200 here, and do so run section router BGP, and let me remove this command, the route map command with this neighbor, say no, and no route map, no route map, and the name of route map is set primary path here also, and do so IP prefix list. I'm going to remove prefix list as well. No IP prefix list, and this one no IP prefix list, and then name of my prefix list. Done. Do so run section BGP. Now you can see we don't have any route map here, right, for any neighbor, and do so IP BGP. Now check the BGP table, still it is not performing load balancing. Best is via 12.1.1.1, right, because of local preference value. Done. Now if you will clear the BGP table, then local preference value will become null for this route as well. Done guys. So let me do, and before clearing the BGP table, what I am going to do here, I am going to perform the load balancing. So let me set router BGP 200, and I am going to say maximum path 2 here as well, and clear IP BGP star soft in, and so IP BGP. Now you can see this router is also performing load balancing for all received subnets, right? So IP route BGP, you can see for all 10 subnets router 2 is performing load balancing. Now let me do one thing, let me verify the connectivity between these two companies network. Like from router number 3, see router 3 is connected with two department, HR department and sales department. I'm going to ping, let's say, finance department in ABC corporate from the HR department of XYZ corporate, and as I told you, last IP address from the subnet is running on router. So let me ping. See the subnet for finance department in ABC is 20.1.1.0/24, and the IP address which is running on router is 20.1.1.254. So say ping 20.1.1.254 and source 10.1.1.254, which is the gateway IP address of HR department in XYZ corporate, and see ping is working, right? In the same way, even you can ping to any other department of ABC corporate, like management department. You can see I'm able to ping management department also. We can ping the sales department 3.254. Yes, I am able to ping. Even you can ping the voice servers like 4.254. Yes, you can see, right? So guys, both companies are able to communicate with each other. Even you can verify the internal communication like ping, and I can ping admin department from the HR department in the same company. So for the admin department, we have what subnet 10.1.3.0/24. So ping 10.1.3.254 and say source 10.1.1.254. Done. All are able to communicate with each other. Now again, let me take you to router number 1. Now guys, we are going to work on the improvement, right? How we can enhance the BGP configuration on router number 1 and router number 2. First of all, so IP BGP, this is the BGP table, right? Here I am not able to see which routes are advertised routes, which routes are received route, right? But I can use the command like so IP BGP and neighbor 12.1.1.2, and I can say show me the advertised route to this neighbor. What routes router 1 is advertising to this neighbor, and see the issue as well guys. Here router 1 is advertising 20 subnets as well to router number 2. Router 2 is the edge router of ABC corporate, right? Means router 2 is advertising all 20 subnets. Then how router 1 is also advertising 20 subnets to router number 2? This is the issue, right? Router 1 is advertising total 8 number of prefixes to router number 2, but router 1 should only advertise 4 subnets, because in XYZ company you can see we have only 4 subnets, we have only 4 departments, right? In the same way for other neighbor also, for 21.1.2, for 21.1.2 you can see it is advertising all 20 subnets, right? So this is just because of initial configuration of BGP. Yesterday we did the initial configuration of BGP on both router. Now what is happening in this scenario? See, router 1 have 2 BGP neighborship, one on fast ethernet 2/0 and one on fast ethernet 1/0. So router 2 is going to advertise all 20 subnets from both link, right? Because router 2 have also 2 neighbor, one on this port, one on this port. So from there both interfaces it will advertise all 20 subnets, all 20 subnets. Now what is happening when router 1 is receiving 20 subnet on this port from neighbor 12.1.1.2, from this neighbor, right? So router 1 is receiving some routes from this neighbor, and router 1 have one another neighbor which is 21.1.1.2. So router 1 is advertising same route to another neighbor. That means it is learning 20 subnet on F2/0 and it is advertising same subnet from F1/0, and same thing is happening on F1/0 also. It is learning all 20 subnet on F1/0 and then it is advertising from F2/0. So first of all you have to stop it. Definitely router 2 will discard it. The reason, when router 2 will receive 20 subnets from router number 1, it will see their own ES number there, right? Because whenever router will advertise route to their eBGP neighbor, it will include the ES number. So when router 1 will advertise 20 subnet to their neighbor 20.1.1.0/24, let's say, right, it will include 2 ES, 100 and 200. Once router 2 will receive it, it will see their own ES number in the update, it will discard it, right? Router 2 will not accept it. But why router 1 is advertising 20 subnets? Like guys, see, for now we have only 4 subnets in both companies, but in real time you can have 1000 number of prefixes. And the link between router 1 and router 2, these links are very critical link, right? Getting my point? So if there are unnecessary traffic on this link, maybe my end devices will get slowness, my end devices will get packet loss, right? Because these two links are shared link, right? All people are sharing these two links. So you have to stop all unnecessary traffic on this two link. How to stop advertising 20 subnets from these two link? In the same way, router 2 is also advertising 10 subnets to their neighbor from the both link. You can verify it simply on router number 2 Just wait, what happened? Yes, on router number 2 also you can see show IP BGP neighbor 12.1.1.1 and advertise dot. See, it is advertising all 10 subnets, right? In the same way for 21.1.1, 21.1.1 it is advertising all subnets, correct? So the second improvement is here. First improvement, you can add the tag number, right? First of all, guys, see, right now I am advertising subnets networks in BGP with the help of network command, right? So run section router BGP. I am advertising subnets with the help of network command, right? So let's say I want to redistribute EIGRP into BGP. Simply what I can do, I can remove these network commands, say router BGP AS number 100 and no network, and let me copy each command. No network, this one, remove it. No network, this one, remove. No network, this one, and then no network, this one. Like this, right? Now do so IP BGP. Now you can see we have only received route, right? Now I am going to redistribute EIGRP AS number 10 here, and then you can define the metric you can call to route map. So as I told you, I want to differentiate the route. Simply what I can do, I can call to any route map while redistribution. Let's say route map Cisco, and in this route map I'm going to match all prefixes, and for all prefixes I will add one tag number. Getting my point? Like that I can redistribute. For now here I am saying, let's say metric 10. While redistributing EIGRP into BGP, it will use metric 10. Now do so IP BGP. You can see we have again all 10 subnets. And if I am redistributing EIGRP into BGP, then it is advertising these two subnets as well, like 13 and 14. But router should not advertise 13 and 14 networks. And as these two are directly connected network, you can see for self advertised next hop is 0.0.0, So guys, how to overcome this issue? Simply see, to match the prefixes I have two options. Either I can use prefix list or I can use access control list. Then we are going to call that prefix list or access list in the route map, right? So first of all, I'm going to remove this command again, say no to this command, and this time I'm going to, let's suppose, create one prefix list or access list number 10, and I'm going to allow or deny 13 subnet 13.1.1.0 0.0.255 and 14 subnet 14 subnet. Then access list number 10, and I am going to permit all 10 subnet 10.0.0.255.255. Like this I can create access list. Now see what this access list will do. This access control list is going to deny these two subnets and will allow all 10 subnets, right? Now let me create one route map here, route map, and name of route map is, let's say, advertise to ABC corporate, ABC corporate. This is the name of my route map, and here I am going to use action permit, and after that if you want to define the sequence somewhere, you can define here, or you can ignore it, leave it for now. Here I am saying match IP address from list number 10. So it will match IP from list number 10, and in the list 10 we are only allowing this subnet, right? And now I can say set tag number 10. Like this also I can do what? I can add the tag number for advertise prefixes, right? But for now leave it. Now I am going to call this route map while redistribution. Say router BGP ES number 100 and again say redistribute EAGRP ES number 10 and matrix, let's say 10, and then let me call to route map. What is the name of route map? Advertise to ABC corporate, right? Let me copy this, and now that's it. Now hit enter, right? And clear IP BGP star soft in and see show IP BGP. Now it is not advertising 13 and 14 subnet, right? It is only advertising 10.1.1.0, 10.1.2.0, 10.1.3.0 and 10.1.4.0, right? And the second issue is show IP BGP neighbor 12.1.1.2, 12.1.1.2 advertise route. So it is advertising 20 subnets as well, but I don't want to advertise 20 subnet as well. So what I can do, again in that access list I can deny 20 subnets. So simply let me modify the access control list, say no access list number 10, and access list number 10, first of all deny 13.1.1.0.0.0.255, deny 14.1.1.0.0.0.255, deny 20.1.0.0.0.255.255, and then permit. I will only permit 10 subnet, permit 10.1.0.0.0.255.255. Even you can use access control list, no problem. Now again clear IP BGP star soft in and show IP BGP. See the BGP table, it is not advertising any 10 subnets as well. Just wait for some time. So access list, we are allowing 10 subnets. Yeah, that is correct. Here we have some match 1, match 2. Here there is no match. So run section BGP, so run section router BGP, redistribution command is here, redistribute EAGRP matrix 10 and match, use route map this one, and in this route map so route map, in this route map it is matching IP from access list number 10, right? And so access list, in the access list we are only allowing this one, and this time you can see we have some matches. So IP BGP, now you can see it is advertising only 10 subnets. These are the received route. Here we don't have any tag number, but we can add. Now let me check the advertised route to their neighbor. Is this router still advertising 20 subnets to router number 2? So IP BGP neighbor 12.1.1.2 and advertised route. It is still advertising 20 subnets. Yeah, actually see, I have applied the route map while redistribution. Now I can apply that route map with their neighbor as well. Like I can say router BGP ES number 100 and do so route map. Let me copy the name of route map. Now I can apply this route map with the neighbor, right? Say neighbor 12.1.1.2 and call to route map, this route map, and let me apply it in odd direction. So whenever router 1 is going to advertise route to this neighbor, it will call to this route map, right? So let me hit enter, and again I am going to say clear IP BGP star soft in, and now you can see so IP BGP neighbor 12.1.1.2 and advertised route. Just wait, it is advertising 0. Just wait, after some time it will start advertising. In the route map, it is denying 20 subnets. By the way, we have to modify the configuration. There is some misconfiguration, but you can see I have achieved my task. Now it is only advertising 10 subnets to their neighbor, right? This time it is advertising only 4 subnets, right? So while advertising dot to their neighbor, router 1 is going to call to route map, and in the route map, whatever prefixes are allowed, it will advertise only those prefixes. Done. Like this, you can configure a route map for all neighbor. Everything is working fine. Let me create some scenario. And guys, before creating the scenario, the most important thing is, let me give you one basic overview of attributes, right? The most common attributes of BGP, like weight, local preference, ES path. You know, weight is Cisco proprietary attribute. Generally we are using weight attribute on Cisco devices. So here I have one PDF. See, the first attribute is weight attribute. Weight attribute is also useful, very useful attribute on Cisco devices for path manipulation, for path selection. So a Cisco specific attribute that is used only locally within a router, right? It is not used to manipulate path for neighbor, right? Because BGP never carry weight information in the update message. It will impact on locally router. It is not propagated to other routers. What is the use case of weight attribute? So see, let's suppose if a company has multiple connection to different ISPs, the weight attribute can prioritize one ISP over other. For example, if ISP1 is preferred over ISP2, a higher weight can be assigned to the route learned from ISP1. Let me give you one scenario here. Let's suppose I have one router R1 connected with two different ISP, one ISP1 and ISP2. Both ISPs advertising guys same subnet, let's say X, right? But as I told you, I want to prefer ISP1. So what we can do, we can configure higher weight value for this ISP, right? Higher weight value for ISP1. Then router 1 will always prefer to ISP1. So actually weight attribute is used to prefer a path, right? Prefer a link, you can say. Got it? Got my point? Now example can be a company XYZ Corporate has two ISPs. To ensure that traffic flow through ISP1 by default, right? What do you want? By default traffic should flow through ISP1. So what XYZ Corporate can do, XYZ Corporate can set higher weight value on routes learned from ISP1. Let me give you example. Like in my scenario, I have two links between company 1 and company 2. Right now router 1 is doing load balancing, so IP route BGP. But let's suppose I want to prefer upper path. I want to prefer upper path. So what I can do guys, I can configure the higher weight value here. So IP BGP. See, the weight value by default for all received route is null, 0, right? Weight value for self-advertised prefixes, weight value is 32768, but for received prefix 0. Now as I want to prefer upper path, so neighbor is 12.1.1.2 on the upper path. For this neighbor, what I can do, I can increase the weight value. Simply I can say router BGP AS number 100 and neighbor 12.1.1.2 and weight is, let me say, 10 here, right? And clear IP BGP star soft in. And so IP BGP. Now see, best path is via 12.1.1.2. What is the reason? See, the weight value over here is 10 and weight value from the other neighbor is 0, right? So IP route BGP. Now it is not performing load balancing. Even you have configured maximum path 2, then also it will not perform load balancing. because this time attributes are not same. Router will perform load balancing if all attributes are same, right? So with the help of wait attribute, what we can do, we can prefer a path. We can prefer a ISP, like between company 1 and company 2, XYZ company and ABC company, we have two paths. We can prefer one path like this, right? Then router BGP is number 100, and here I have configured wait value 10, wait, sorry, neighbor 12.1.1.2 and wait 10, like this. If you want to prefer the lower link for the other neighbor, you can configure higher wait value, right? So this is one attribute. I am going to remove this command, wait, say no neighbor 12.1.1.2 and wait 10, remove it and clear IP BGP star soft in. Even we can add wait value with the help of route map, right? Now show IP BGP, again it has started performing load balancing. Okay, but wait is Cisco proprietary attribute, you can only configure on Cisco devices. And now next attribute is local preference, right? Most commonly used attribute in real time. Done. See, the description of local preference indicates the preferred path for outgoing traffic, right? For outgoing traffic going to ISP or to the companies, right? BGP always carries local preference value for their iBGP neighbor, but in my scenario, see, the neighbor is eBGP. For eBGP neighbor, router will not carry local preference value. Done. It is shared within ES, here you also you can read, but not advertised outside of it, right? So local preference attributes work within ES. Use case: in a scenario where a company has multiple exit point or exit out from its ES, right? So let's suppose example, XYZ corporate has two data center in different location. The company prefer that all traffic to a specific destination goes through data center 1. So what you can do, a higher local preference value is set for routes through data center 1, right? XYZ company has two data center in different location. The company prefer that all traffic to a specific destination goes through data center 1. Like this is my company XYZ company and two data center, and then there is one destination, right? For the particular destination, I want to prefer data center 1, DC1, DC2, DC2. So what I will do, while advertising route to DC1 and DC2, here I will set higher local preference value, right? The next attribute is ES path attribute. Again, this attribute is also, guys, commonly used attribute in real time. Whenever a route will pass ES number, autonomous system number, router is going to include that ES in update. A shorter ES path is usually preferred. Let's say between source and destination, between company XYZ and ABC, there are multiple ESs, right? This is ES number 100 again, or ES number, let's say 200. This is ES number 200. This is ES number 300. This is ES number 400. So now ABC is advertising some routes to XYZ. What will happen? Let's say here I have one subnet X, right? Here ES number is 200, here ES number is 100. When XYZ company will receive X subnet from this side, from the upper path, how many ES number will be there, guys? 200, 400 and 300. When same company will receive X subnet from the lower path, how many ES number will be there? 200, and here also you can see 200, 200, right? For IBGP it will not include the ES number. So XYZ company will get to know, okay, lower path is the best path because here we have less number of ESs. Means routes are crossing less number of ESs. Done. And it is used for path selection as well, for path manipulation as well. What we can do, we can add the ES number. Like in my scenario, right now router 1 is performing load balancing for these subnets, and so IP BGP, see this is only 200, right? SS is only 200. Now let's suppose I want to add one more ES from the lower link, right? Because I want to make upper link as primary link, preferred link. So what I can do, I can add one extra ES over here. Extra ES over here. Simply I can create one prefix list to match the networks, like IP prefix list, and let's say ABC Corp prefixes. For this prefixes, I'm going to match subnet permit 20.1.0.0/16, right? So this prefix list is going to match this subnet. Now route map, and name of route map is, let's say, AS prepend, right? Then permit, and let me say sequence number 10. Here I am saying match IP address from prefix list, this one, ABC corporate prefixes. So it will match. I can say set AS path prepend, and here I am going to, let's say, add some ES 500, 600 and 700, right? Now I am going to call this route map with neighbor. So router BGP AS number 100 and say neighbor. Which neighbor? 21.1.1.2 on the lower link, and call to the route map. Route map, and name of route map is AS prepend, right? And then in which direction? In direction. Whenever you will receive route from this neighbor, use this route map. Now say clear IP BGP star soft in. Now show IP BGP. See the BGP table. It is so run section router BGP. Just wait. Is it applied with the neighbor? Yes, it is applied with the neighbor. So what happened? Why it's not working? Router BGP AS number 100. Let me remove this command. Say neighbor and 21.1.1.2, and the route map, name of route map was ES prepend, and direction in. Let me say no to this command, and clear IP BGP star soft in, and so IP BGP. Yeah, again it is receiving. Let me do one thing. See, the requirement is, now my requirement is, the scenario is router 1 should receive all traffic from ABC to XYZ from the upper link, So what I can do, I can add some more ES number on the lower link. And I have already route map for this. See the route map. So route map, this route map is actually matching IP address from this prefix list matching IP address from this prefix list. So IP prefix list. In this prefix list, you can see the subnet is this one, 20.1.1.0. So I need to change the subnet here. For 10 networks, I am going to add the ES. So say no IP prefix list, and this one, and now IP prefix list, let's say X Y Z subnets, and then permit sequence number XYZ permit, and then subnet 10.1.10.0/16 less than equal to 32. Now do so route map. In the route map, we are adding these ASs. Done. Now let me do one thing. Let me call this route map with neighbor router BGP number 100 and neighbor 21.1.1.2 route map, and the name of route map is AS prepend and direction out. Clear IP BGP star soft in, and so IP BGP. Here we are not able to see any change. Let me take you to router 2. So IP BGP 20. For 10 prefixes, still it is performing load balancing. Clear IP BGP star soft in, and so IP BGP. Now best path is via 12.1.1.2 only. Then guys, we have next attribute, that is origin code. So you can use the origin code as well, like specify how routes was learned from IBGP, from eBGP, from the redistributed, like that, right? Company XYZ Corporate received the same prefixes from two different sources, one via IBGP and other via eBGP. Since IBGP is more preferable, right? The route with the IBGP origin is chosen. Done. Then guys, we have what? Metric. Metric is similar like metric in IBGP, and lower metric will be always preferred. Then guys, we have what? Next hop attribute. Indicate the IP address of next hop router that should be used to reach the destination. Then we have community attribute, like we can add the tag value as I told you in the beginning, right? That is for policy based routing, for the traffic engineering, for route filtering, for route influencing. What we can do, we can add the tag. So this is all about adding tag, right? So these are guys basic attributes commonly used in case of BGP. Now here, let me create some scenario. Let's suppose my requirement is, for the security purpose, I don't want to advertise server or admin subnet, these two subnets, to ABC Corporate, right? I only want to advertise this subnet and this subnet from router 1 to router number 2. What I can do, I have multiple attributes here. I can use any attributes according to our requirement. Like, see, I want router should only advertise this subnet and this subnet to router number 2. What I can do, guys, I can match these two subnet by using prefix list or ACL. Then I will call that to the route map, and in the route I can apply that route map with neighbor, right? I can apply that route map with neighbor. Let's suppose config t IP prefix list, let's say name is ABC simply, then say permit and 10.1.1.0/24, then permit 10.1.2.0/24. Rest all are deny IP prefix list, deny 0.0.0/0 less than equal to 32. Now router, I can say router BGP as number 100 and neighbor 12.1.1.2 and prefix list. Prefix list name is ABC and then in which direction? So in odd direction. Now see, so IP BGP neighbor 12.1.1.2 advertised route. Just wait, clear IP BGP star soft in, it will advertise to prefix. Now you can see it is only advertising these two prefixes. In the same way, from ABC corporate, I want to advertise only sales or let's say voice server subnets. So I can configure the prefix list there and I can apply that prefix list with their neighbor, right? So guys, we have multiple options in BGP according to our requirement, according to our scenario. We can enhance the BGP configuration here. Okay, so again video length is getting lengthy. What I will do, maybe I will make one another part of this series. That's all for today. Thanks for watching guys. If you have learned something from this video, please hit on like button.